Hello everyone, welcome to next numerical problem of electrical machine. And today our numerical problem is a 4-pole wave winding DC shunt motor running at of 1200 rpm with speed is 1200 rpm and with 200 copper conductor have an armature resistance of 0.5 ohm and shunt field of 120 ohm. If supply of 250 volt is provided, then find back EMF value of armature current if it is 10% more than shunt current, flux, and last one is torque. In the question given, number of pole equal to 4, A equal to 2, and because it is wave winding, so A equal to 2 and N equal to 100, 1200 rpm, Z equal to 2000, Ra equal to 0.5, RSS 120, and Vt is equal to 200 volt. RSS is shunt resistance. So we have to find back EMF. And now this is the circuit diagram. This is the shunt resistance. Shunt resistance is always in parallel. So uh, and this shunt resistance is in parallel. Now we know back EMF equal to Vt minus IaRa, and Ia equal to It minus ISS, and Vt equal to VSS because parallel combination. So ISS equal to VSS upon RSS. Then we have value of VSS 250 and RSS 120. So 2.083 ampere, and 10% of RSS is equal to 0.028, and Ia equal to ISS plus 10% of ISS. So Ia equal to 2.29 1 ampere, and back EMF equal to 250 minus, put all these value in this, and Vt equal to 250 uh, and Ia value of Ia is 2.291 into 0.5, so we can get back EMF equal to 248.85. And next one we know the value of back EMF equal to 5Z NP upon 60A. Then we can get the value of flux. This is the value of flux. Put all this value, you can get the value of flux. Value of flux is 0.003 Weber. And the last one is torque. And this is the value of torque. Torque equal to Z phi Pi upon 2 pi A. Put the value of phi, Z, P, and I and O, then you can get the value of torque. The value of torque is 4.375 Newton meter. And another problem is a 4-pole 250 volt DC shunt motor has 500 wave wound conductor. Armature resistance is 0.25 ohm and field resistance is 125. Flux per pole is 0.02 Weber. If the motor draw 14 ampere from the supply, then find the torque and speed of the motor. We have to find the torque and speed of the motor. First of all, value of number of pole is 4, Vt 250, Z 500, A equal to 2, it is wave winding, so A equal to 2, Ra equal to 0.25, RSS equal to 125, and phi equal to 0.02, It equal to 14 ampere. We have to find the value of torque and speed. We know uh, Eb equal to Vt minus IaRa, so ISS equal to Vt upon RSS. Then you can get 2 ohm, and It equal to Ia plus ISS. So 14 minus Ia equal to 14 minus ISS, that is 2, that is 12. This is ampere, not ohm. And Eb equal to 250 minus 12 into 0.25, so 247 volt. And the formula of torque is 5Z Pi upon 2 pi into A. So 0.02 into 500 into 4 into 12 upon 2 pi, that is 38.19 Newton meter. And we know the formula of back EMF. Back EMF equal to phi ZNP upon 60A. Then N equal to EV into 60 into A upon phi ZNP. Put the value of EV, A, phi ZNP, we can get the value of N, and the value of N is 741 RPM. And next numerical problem is an 8-pole DC shunt generator has 778 wave connected armature current running at 500 RPM. Supply a load of 12.5 ohm resistance at a terminal voltage of 250. The armature resistance is 0.24 ohm, voltage of 250. The armature resistance is 0.24 and field resistance is 250. Calculate the value of armature current, induced EMF and flux per pole. First of all, the value, this is the data given, where P equal to 8, A equal to 2, Z equal to 778, N equal to 500 RPM, REL equal to that is load resistance equal to 12.5 ohm, and VT terminal voltage 250, RA 0.25, RSS 250. We have to find IA, EZ and phi. The IA equal to IL plus ISS, so IL equal to BL upon RL, then you can get the value of IL. And RSS equal to BL upon RSS, so 250 upon 250, that is 1 ampere. Then IA equal to IL plus ISS, that is 20 plus 1 is 21 ampere. And EZ equal to, that is generated EMF equal to BL plus IARS, so 250 plus 21 into 0.24, that is 255.0504 volt. And flux per pole, that is EZ equal to phi ZNP upon 60A, so phi equal to EZ into 60 into A upon ZNP. Put the value of all this, that is value of EZ, A, Z, phi, NP, then we can get the phi. This is the value of phi, 0.009 Weber. So we have to find the value of IA, EZ and phi. And the next problem is a 220 volt DC shunt motor has an armature resistance of 0.5 ohm and run at a speed of 850 RPM. When talking of full load current of 32 ampere, shunt field resistance is 110 ohm. Calculate the speed at which the motor will run if 1.5 ohm resistors were introduced in the series with the armature. This is the circuit diagram, and this is the given data. Given data is BT equal to 220, RA equal to 0.5, N equal to 850, and IL equal to 32 ohm, RSS equal to 110 ohm, and RESC equal to 1.5. So to find the speed of motor, first of all, EB equal to VT minus IARA, and IA equal to IL minus ISS. So IS is equal to 220 upon 110, that is 2 ampere, and then IA equal to IL minus ISS, so 30 ampere, and EB equal to VT minus IARA, then we can get the value of EB 205, and EB directly proportional to N5, so EB1 equal to N1, Phi1 equal to EB1 upon N1. Put the value of EB and N1, you can get the value of phi. Similarly, this is the condition second. Phi1 equal to phi2 equal to phi, so 0.021 Weber. RES equal to 1.5 is introduced in the machine in series with RA, and this is the circuit diagram. This is RESC, and then EB2 equal to VT minus ISC into RESC minus IA RA. So put all this value, we can get the value of EB2, that is 166, and EB2 equal to N2 phi2, so N2 equal to EB2 upon phi2, then we can get the speed is 663.9 RPM. In the question we have calculate the speed of the motor. So This is our final answer. This is the speed. And the next problem is the armature of 12 volt DC shunt generator has 50 slots with 12 conductors in each slot in wave winding arrangement. The generator is running at a speed of 625 rpm and supply a resistivity load of 150 ohm at a terminal voltage of 300 volt. The armature resistance is 0.5 ohm and field resistance is 60 ohm. Find armature current, generated EMF and flux per pole. First of all, the given data is number of pole equal to 12, A equal to 2, N equal to 625, RL equal to 15 ohm, VT equal to 300 volt, RA equal to 0.5 and RSH equal to 600 and Z equal to, in the question given, 12 slots. And each slot arrangement is 50 slots with 12 conductors. So 50 into 20, then we can get 600. The value of conductor is, that is Z equal to 600, and this is the circuit diagram. We know EG equal to VT plus IARA, that is 300 plus 25 into 0.5, that is 312.5, and IA equal to IL plus ISS. So IS is equal to 300 upon 360, that is 5 ampere, and IL equal to 300 upon 15, that is 20 ampere, and IA equal to IL plus ISS. So 20 plus 5 is 25, and we know E is equal to 5Z NP upon 60A. Then put the value of then phi equal to Ez into 60A upon Z NP. So put the value of Ez A Z NP, we can get the value of phi, and the value of phi is 0.0083 Weber.